Coming up on This Week in Radio Tech, it's a subject that some people have been avoiding, some people have been working on. It's getting all these control protocols over IP to, well, first of all, understand them and maybe get them to work together. I don't know. Anthony Kuzub from the CBC is here. He's an expert. It's coming up next on TWiRT. This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. And by the CalRec Type R console system. Type R is a brand new, modular, expandable IP-based radio system from CalRec Audio. Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone to the light bulb at the top of the tower. Have you noticed I've quit talking about my beacon that I have here? I still haven't rebuilt that thing. It's sitting in the next room, in the server room. I've got to rebuild that. Welcome in. I'm Kirk Harnack, your host. This is our 471st episode of This Week in Radio Tech. And we try to come to you every single week. Obviously, we've missed a few here and there along the way, but we're almost 10 years old, and we have almost 500 episodes. We've done a pretty good job, even though it took a summer off. I'm here in Nashville, Tennessee, in the Telos Alliance studio. Thanks a lot to the Telos Alliance, my employer, for making a little bit of time available every week for me to do this and supplying some of the gear that we have here in the studio at the Telos Alliance studio here in Nashville. We talk about broadcast technology and audio over IP, RF sometimes. Hey, we've even had a few episodes where we've talked about tape and good older technology, but we usually try to focus on what's current and what's coming up and some practical things. So Chris Tobin is normally with us at this point, but Chris is on assignment on Long Island, and he's getting something done, says he'll try to join us during the show. But we've got a show for you today that I think is amazing because it deals with a topic that is of great importance that nobody's really figured completely out yet. Well, maybe except for our guest. That's why he's here. I want to welcome in Anthony Kuzub. Anthony, welcome into This Week in Radio Tech. How are you?
Good day, sir. How are you?
I'm good. You are. You're bundled up. You're cold?
Well, I'm in my garage. I'm out here in my garage, and yeah, it's getting cold. Not gonna lie.
That is it is quite an assortment of tools you've got behind you there. That's well,
hold on here. Let's take you for a wee little tour. Look at this. So what I do in my garage is I rebuild vintage mixing consoles, and what I have is I have modules on my bench for test. Okay, wait for it.
Yeah.
And then I have all of this test equipment that is set up to test these modules out. And then on the other side of the wall, I've got a machine shop. Do you want to see the machine shop?
Oh my goodness! Sure. Take us over there.
So I have a wood shop on one half of the garage. I have a mixing console that's under test here, and then I have milling and engraving for like little channel buttons, and then I have a lathe and tools and stuff to do all that type of repair work in my little tiny garage. So I'm just trying to create something a little bit unique for myself. And
I will sit right here and make a confession. I am breaking a commandment because I'm coveting. I am coveting.
It's my garage mahal, I like to call it.
Garage mahal. Oh my goodness. Hey, I got to tell you, now you're hooked up to a good internet connection at your garage mahal, right?
Seems to be. Is it doing weird things?
No, it's doing great. I was going to talk about a different internet connection. Sometimes when Chris Tobin and I need to go on location, when we're on remote or on location or doing an OB, as they say outside the U.S., an outside broadcast, Chris and I use Max Connect. This is an amazing service from Josh Bone at Bone Broadcast, BOHN, but you can go to Max Connect. I know it's spelled funny because you know the internet, maxconnectwireless.com. And it's not just a data modem. It's not just a data modem. Yes, your service is with either AT&T or Verizon, or you can get both, 2 SIMs in this Max Connect, but it's a special service. You get priority over all those other schlubs at the parade, at the ball game, wherever you're broadcasting from, you get priority over everybody except for first responders and maybe the Secret Service. But I think Secret Service has their own stuff. Point is, Everybody else in the stadium, is on their phone at halftime, doing Facebooking or calling mom. And guess what? You've got data with Max Connect. We use it because it's reliable. I've done remote broadcasts with this, video broadcasts. Did one for the SBE where I thought my T-Mobile service, which I love, I thought my T-Mobile service was going to get me what I wanted in terms of video connectivity. It was measuring like 15 megabits up. But then we started getting a lot of packet drop. Switched over to a Max Connect, and it was only measuring 5. But you know what? It was 5 megabits solid the whole time. And that's exactly what we needed. And broadcasters are loving this thing. You can use it at a transmitter site as a backup STL, even as a main STL. So, your tower falls down. That happened in Louisville, Kentucky. An STL tower fell down. I don't know what they used, but they could have used Max Connect to get their IP audio out to the transmitter site. You can use it for remote broadcasts. You think of ways how you could use Max Connect, and check it out. Max Connect, spelled funny, wireless.com. And you're gonna enjoy the service. And look here. I'm in my basement. I got all these 4 bars. If I hooked up to the LAN connection and did a speed test, promise you, 5 meg up, 5 meg down, absolutely solid. Not a packet lost. Probably. It's really good. All right. Hey, it's This Week in Radio Tech, and I'm Kirk, and we have Anthony here with us. Anthony, we're going to talk about what I might call a control conundrum. We've had audio over IP. You would call it that? We've had audio over IP for a few years now. And, I've been involved at Telos with Livewire AOIP for a good, the first time I ever showed it anywhere was literally 17 years ago in Australia. It was the first place I saw it. Yeah, we did a Livewire demo there and wowed them. And we started getting installations like 16 years ago in Auburn, Alabama, and then in New York City at WOR. Radio with Tom Ray, and then it just took off from there. Now there's about, there's other brands too, but I know there's just about 10,000 Axia Livewire audio consoles out in the world right now. We figure there's well over 500,000 Livewire streams going on. So, and then along came AES-67, a standard that everybody can join in on, and then we have the SMPTE standard 2110-30. You can help us understand the difference there, but there's a problem because we don't just need audio, we need something else. Tell us what the problem really is for broadcasters that want to use IP.
There are multiple ways to connect devices, and once they're on a network, you have to be able to control these devices. And you have your console surface, and you have your, triggers that, trigger cues, and you have your GPIs that are buttons that the talent push. And you have all of these other things that are not necessarily audio, and you're not necessarily moving audio with them. They're in parallel to audio. And we don't really think about them too much. We don't really talk about them too much because in the past they used to be a very complex, very proprietary series of wires that were jumbled together in these black mystery boxes that some guy on the 10th floor knew what they do, and there was no documentation, and that was his job, was to make these control parameters and these control features do magic within radio studios. Turn on lights, cough, shut off a microphone, turn on the indicator light, turn on my Christmas lights. How do you make these things go off and on through some type of IP command? And how do you make these streams connect with one another? So if you have AES-67 here and AES-67 here from two different vendors, how do you make those two vendors, line up and actually make interconnection with one another? So there is what they call the full stack. There is the pyramid from the EBU, and there's a graphic for this.
Tell you what, let's look at that graphic in a couple of minutes. Right after our first break, I got to tell our audience, we have a lesson for you from an expert. Anthony Kuzub has been doing this for a while, and he's been getting his hands dirty at the CBC, making things work together. And so this is not just pie in the sky. This is real. Here's what I've done kind of information with all different kinds of standards. Tell you what, Anthony, give us a little preview. What are some of the control standards that we're going to be hearing about in this episode of TWiRT?
So there are 3 rabbit holes I went down. I was doing a presentation at CCBE. I went down 3 rabbit holes. I went down the MIDI 2.0, the MIDI 2.0, the AES-70, as well as the NMOS rabbit hole. And then I'm going to talk about one because it's a bit of a farce out there in control protocol land. So I invented one called the Emoji Description Protocol. So we'll talk a little bit about the Emoji Description Protocol too.
That would be EDP.
EDP, well, yeah, EDP for sure. It's like an SDP.
And there's probably it wouldn't be a great protocol unless there's an emoji that means EDP, right?
Well, so I've gotten, like all rabbit holes I go down, I went down the emoji rabbit hole. So I'm trying to figure out how I can propose new emojis. This is a very difficult process, but I'm working on it.
I'm sure it is. Okay, we're talking, and so stay tuned. We're actually going to have a lesson today with graphics. You're going to take notes. If you're listening to the show, great. Glad to have you listening, but you're going to want to watch this episode of This Week in Radio Tech. It's visual with some graphics that Anthony has put together for some presentations and seminars. We get to see them today. And by the way, at the end of the show, we have got a tip of the week that is just amazing. Wish we had this years ago, but we got it now. So you're going to want to stay tuned for that. This Week in Radio Tech is brought to you in part by my friends at Angry Audio, angryaudio.com. Let me show you a couple things from Angry Audio. This is so slick that if you're not using it, you need to check your temperature. This is really great. This is the Guest Gizmo from Angry Audio. The Guest Gizmo, you can drill a round hole in your furniture and drop this puppy in, and you get a square top, and it just fits beautifully in a 2 3/4 inch hole. So it's easy to put in. You don't need a wood router. You don't have to be an expert. You just got to drill a nice hole, you know? And then you drop this thing in. What's in here? Well, there's a headphone amp in here. You give it power. Yeah, it's got a little power input, of course. It's got a logic input. You can read about how that works, but it's got some flexibility there. It has left in and right in, and it's got an insert point in there. But what it gives the guest is headphone and volume, plenty of loudness, and a cough button right here. Plus, it also has the ability to light up the tally light on one of those microphone booms, you know, with the LED tally light ring. So this is super cool. The Guest Gizmo, just one of the gizmos available from Angry Audio. And the other thing, Angry Audio recently acquired Studio Hub, and that means you can get all the Studio Hub stuff that they stock, and you can get service parts for things that are no longer made, like the Millennium consoles from Studio Hub. They've got those at angryaudio.com. One of the things that you love, a lot of people have installed these Studio Hub headphone amps. They were nicely priced, very reasonable, and I've got some of these in my radio stations. They're great, I think. And this is a cool little bracket. If you've never seen it before, you can use this bracket. I've got a couple of these in the, on those equipment shelves, the equipment pods that sometimes you put on top of the console table, and you leave the bottom open like a little garage. That's where I got mine. And that way my disc jockeys don't run their legs into the headphone amp. Don't have it underneath the counter. I have it in the little garage. But if you do put this underneath, you got this is really heavy duty, strong plastic, good ABS stuff. And of course, it's a Decora hole there. And so the headphone amp just goes right into it like that. If you haven't used one of these, highly recommend it. It's a Studio Hub from Angry Audio. The headphone amp, plenty loud. It's got audio in, it loops in and out, and you can get the power on the same connector right there. With the Studio Hub standard. So check that out. Angry. Oh, and by the way, they think of everything. If you mount this thing vertically, it comes with the labeling on the headphone amp for a vertical mount, or if you have it dropped into your console surface or into your tabletop. But they also give you a horizontal label as well. So if you need to mount this horizontally, you can stick that label, pull the knob off, then stick the label on, and you've got a horizontal, and it all reads correctly. And by the way, it's got both headphone sizes. It's got country and Western. It's got 1/4 inch and 1/8 inch headphone jacks. So give those disc jockeys some flexibility. Thanks a lot, Angry Audio. Check it out. Go to the web, angryaudio.com. They have a new thing, their new Bluetooth audio gadget. That's really smart. I hope to show you one of those in the coming weeks. Really smart people at angryaudio.com. Thanks a lot for sponsoring the show. All right, we're with Anthony Kuzub. I'm Kirk Harnack here, and Anthony is going to run us through a terrific lesson on all these control. I'm sorry, what was that? Oh, Chris is on. Great. Hey, can you bring him in? Hey, Chris.
All right. Hello there, gentlemen. How are you?
Hey.
I'm in not my usual location.
I can see, and we had
you. Good. Yeah, I'm at a diner here in Long Island.
You two know each other from CCBE, I'm sure.
Definitely. Yeah, CCBE and all kinds of crazy stuff in New York City. Yeah, absolutely.
So, Chris, I didn't get to brief you very much on the show, and so my plan is just kind of sit back and listen. May throw in a question here or there, and you're welcome to too. Anthony's going to take us through some graphics, some steps, and some for the different control protocols that he's been wrestling with and trying to find satisfaction between and among getting stuff to talk to each other. And I'll preface by saying, of course, the basic control protocol that we as broadcasters have dealt with for years is the good old GPIO, general purpose input output. That means a contact closure or a collector to ground closure, and then typically an LED sort of opto-isolated input so that we can tell a piece of equipment, do this, do that, and a piece of equipment can put a contact closure out to the world. But that's been around for 100 years, and maybe there's a better way to do that over IP. Problem is there are different standards, and so Anthony's going to carry us through setting this up and taking us through these different standards. And so, Anthony, tell you what, rather than me interrupt you, why don't you just kind of ask for the graphic you want, and you go right for it like you're making a presentation. Would that be all right?
Man, cheers, Kurt. It's really nice to be given the opportunity to do this. It is something. You're right. It's not a very healthy conversation thing that you have at dinner unless you're hanging out with Chris or Greg Shea or any of those guys. I once went to a protocol party for the Ravenna protocol, and it's like, man, I realized I'm at a party about a protocol. So, it's you've gone too deep when you're at a party about a protocol. But right now in the media business, it's hard to deal with these protocols because there is the walled gardens of manufacturers, and I watch a lot of Game of Thrones, and these they don't want to work with one another, and so when you have walled gardens, you want to either destroy that wall and conquer it, or just sneak one or two by and have a little niceties, but sometimes they don't interop with one another.
Before the break, you mentioned a pyramid. So you want to? That was your first slide, I believe. You want to start with that?
Sure. Well, what there is there's a bunch of organizations that are interested in having a full stack. And when we say full stack, well, like I said, we have AES-67, we have the media that is able to be transported, and that's the tip of the pyramid. Because we have 2110, we have AES-67, and we have this dual link redundancy, which is -7 of 2022-7. That is kind of solidified in standards. But there are certain things that are dynamically moving targets in the world of IP. Timing and synchronization. How do we actually, synchronize multiple nodes together? And in the case of AES-67 and 2110, we're using something called PTP, the Precision Time Protocol, and this is something that is very well established, and that's outside of the broadcast industry. And the broadcast industry is very, I'm going to use the word glacial for development. In the world of IP, in the world of the internet, things move at a very, very, very different rate than the world of broadcast audio equipment. So we are leveraging something that is established in the IEEE. But what isn't established for these media networks and media nodes is a common method of discovering these devices. I plug something in, How do I know it's working? I plugged something in. How do I know it's got the right IP? I plug 10,000 things in. How do I configure those things? Well, right now we're finding, because these at the CBC, we're finding because a lot of these devices don't have any common discovery connection method, that we are manually configuring thousands and thousands and thousands of devices manually. And when one device, like a video device, can have 2 multicasts for video, and then it has 2 multicasts for surround sound, then it has 2 multicasts for the second video program, then it has 2 multicasts for closed captioning. You start getting into these IP addresses where you're starting to, I think we're well past managing 100,000 IP addresses, and we are experiencing, it's a very manual process. So it's not, wouldn't it be nice to have a better way to discover it and connect it? And this is what the NMOS standard suite of protocols is trying to offer the industry. From there, well, now that it's, I know that there's a multicast stream out there on the network. How do I make that connection from one device to another device? So that is -5 of the connection management. Then because for some reason, right now on AES-67 and on these networks, it's really easy to move 1 million channels of audio, but it's very difficult to move one. It's very difficult to move one channel of audio, because if I have a multicast stream that has 64 channels, it takes the same amount of effort to program and manipulate that multicast as it does to move a mono source. So it's never been easier to move hundreds of channels of audio, but it's never been so difficult to move one channel of audio. So there's a portion of NMOS ISO 8, which handles the moving and mapping of channels to the right source. So if something comes in and it needs to be moved from channel 1 to channel 3, there's a mapping that has to happen. And today I'm going to talk about IS-07, which is the event and tally. So the button that you have on for the angry audio thing, when you push that button, that cough button, that is an event. And previously, we always thought about wires. We always thought about contact closures. We always thought about some type of interrupt. But I'd like to say, stop thinking about wires and start thinking in terms of everything as an event. And when you start bringing down, you have your mixing console there, Kirk. You move the fader up. That's an event. You push a button. Okay. That's an event. So those events can trigger different things. In these legacy modules that I repair, when you put in a submaster button, there was a ribbon cable that had a, goes to a pin, and that contact closure event could be picked up someplace else and trigger something else. So we want that same type of functionality in our mixing consoles. So you have to treat every change as an event, and every indication is, well, I've made a change. Well, I need an indication of a change. So you see, I'm starting to go deep on this, and there's this thing I like to call the audio onion. And there's a graphic for this. And the audio onion is these layers that you get yourself into when you start pulling apart these events. And the more layers you pull off, the more you want to cry, is really what it comes down to. So if you and me are the user, you're sitting down and you, the user, are generating incidents. Well, those incidents have to be processed by some type of logic, and that logic does things, whatever it does deeper in the onion, I don't care. But that logic has to be presented back to you as an indication. And for me to be able to even access that layer of the onion, I have to have a session that has access to my device. And I have to have access to those functions which allow me to make audio changes. And those things are presented back to the user. And then, even deeper is the microphone, the wire, the box, and the speaker. And I'm not even going to talk about those things anymore because, you've got millions of gateways that allow you to access these features on a network. With the Audio Onion, like I say, none of these things line up between manufacturers, and there's a couple things that you can do, but the simplest one on a mixing console, and it's not so much for radio mixing consoles, but it's for consoles that are in, like you said, the imaging studios. It's in the live sound industry, the front of house industry. There's way more front of house consoles sold in North America than there are radio broadcast consoles. Churches alone buy way more front of house mixing consoles than all radio consoles sold across the US, I would say. So you have a protocol that has existed in mixing consoles there that not a lot of people talk about, but it's actually MIDI. And MIDI has been around since the 80s, and it's the music instrument digital interface. I had a guy come into a music store I worked at one time and ask for a M1D1 cable, and I had to think about that thing. So from now
right
on,
over there
it's
by the R2D2 cables.
Exactly.
Now MIDI. So look, I'm steeped in broadcast, and I may go to church, but I'm not involved with the front of house or the mixing, anything like that. We've had guests who are, but I didn't know that MIDI was still a popular thing in pro sound. I had no idea. So, wow.
Well, how do you test a mixing console really fast? And it's through automation. All this stuff that I have in my lab here, it's for automating test and measurement. So if you need to move a whole bunch of mixing consoles really, really, really fast, you need a way to program that information into your mixing console, do your measurement with like an audio precision or whatever. So a lot of companies, they still use MIDI to program the mixing console, test the paths, and ship it out as a function. So all of these consoles have these serial connections, so they can test them much quicker. But you can also run events. You can trigger events. You can automate it through any type of like sequencer or Pro Tools. So one of the newest developments is MIDI 2.0. And MIDI 2.0 is a future forward thinking version of MIDI. And one of the things that is really cool about this is it's compatible with all previous MIDI devices. And, take a guess as how many MIDI devices there are in the world. And I would say in the billions. It's in the billions. So you can have an old keyboard, and that old keyboard can use this new MIDI environment that they're proposing. And it's in development, and it's being developed by a whole bunch of different user groups. But the cool thing about it is now you can do gets and sets and recalls, just like SNMP commands over MIDI. So if you want to recall your piano or your organ or your guitar or your digital banjo, you can recall those profiles as a part of this.
But you're not talking with MIDI now. Of course, MIDI, I'm thinking of those multi-pin DIN cables, but you're talking about MIDI over IP, right?
Well, I'm talking about it being agnostic because, it can also come over USB, right? Okay. So there is already an RFC for MIDI over IP, and really it's just asynchronous commands. So it just fires out commands as fast as it can, and it's just a it's as many serial commands as they can possibly do in a second. So it's based on a clock rate. So it's agnostic to what it's being transferred over. But the one thing that this has is it has these profiles. So a mixing console would be a profile. So imagine you're at a gig and you have all your cues and your commands programmed into your console. Well, all you do is you pull out one console, you put in another console, and hopefully all of those cues work because the profiles are designed to interoperate between all of these two things. So it's very interesting. I don't see it taking off too much in the broadcast industry, but I do know, I go into, I see these, 8x8 trigger buttons that, that trigger some kind of cue or trigger some kind of sound effect. Those types of soundboards are there for that. But in the broadcast world, we're going to see a lot of AES-70. And what AES-70 does is it breaks it into this device model.
Yeah, let's look at that.
The device
graphic.
model.
Okay.
It's well, every console has a worker, right? So you would have a worker that is like a gain control is a worker. A level meter is a worker. A switch is a worker. Then you have agents which modify and assist these other things. So these agents modify these workers. And then of course you have all the things you need to do. You need device security. You need firmware managers. You need libraries. This type of stuff is all covered in the device model by AES-70, but it's broken up into two parts or three parts. And the first part is called the framework. And what they have is, next slide, they have all of these root blocks that connect to one another to make up a device. So this block feeds this block. And if you go to the next block, you'll see what an average mixing console actually looks like as a microphone preamp. So you have next slide. You'll have
slide
figure
number 5,
B3.
Yeah.
Okay. You'll have a two position switch. Okay, well that's a worker, and that worker changes a pad, preamp gain, and all of these blocks can be moved within one another. Like you can move the parametric EQ between here and here, because what you're doing internally is you're changing the order in which the DSP processing actually gets activated. With that, you need to have control for all of these things. And this is where AES-70 breaks it up into what they call class structures. And the next slide shows some of these class structures. And in terms of programming, there's a couple really big ideas and concepts in programming. And this one is a very object-oriented programming. And when you have objects, you want to contain them within this class structure. And this class structure takes all of these workers, these sensors, these blocks, and these matrices, and it gives values to all of those things. Think of it like SNMP trees. So as you go from a control class, well, within that control class, there's a worker, and within that, working class is an actuator. So as you add all of these elements together, you start building on what a device could actually be. So there is, a mixer would have actuators and sensors, and it would have faders, which is an actuator. But then you would have a sensor that returns the level of the volume. So there's then how do you transfer it from one to another? So on slide 9, there's one part of the AES-70 protocol, which is back one. There is sorry, my numbers are off by 1. I apologize. So this is the very simple binary protocol that you move messages in. So very much like MIDI, you have a command, you have a method, you have the parameters of the method, and you just shoot them off in one string of commands. AES-70 is, it's a very low level binary control protocol. So its star is that it is super efficient. It is such small amounts of data controlling such primitive little things. And when you have small amounts of data, of course, what you're doing is you're eliminating latency from the structure of your commands. And when you eliminate latency, it feels like you're touching two pieces of wire together. And that's really what we want in terms of control.
So, wow. And I've heard about AES-70. And in fact, at my employer at Telos, we made a video about it that, hey, AES-67 is done. We're doing that. And next we need a control protocol. We're looking to AES-70. But we know there are other, I'm not sure AES-70 has been picked up by manufacturers as quickly as we'd like. And there are others as well. We've reached the halfway point in our show. We're with Anthony Kuzub. He's working at the CBC in Toronto, Canada. where he's making these different protocols work together, because different brands of equipment speak different things, and that can be a little frustrating. Right now, we're getting an overview of these different control protocols. Really important stuff for the all IP world that we're headlong going into. Chris Tobin is here. He's at a diner on Long Island, and tell you what, we're going to take a quick break. When we come back, we're going to start talking about this thing called NMOS, and that I'm hearing a lot about NMOS. So I got to hear Anthony's take on NMOS, what it stands for, and how it's being picked up, maybe in the television world more than the radio world. So we'll see about that. This Week in Radio Tech, episode 471, is brought to you in part by Broadcasters General Store, and they're the place to go if you need this little mixer. It's the Broadcast Tools Pro Mix 4. Now, we're talking about all this future stuff. Sometimes you just need something simple, and here's simple. The Pro Mix 4 is a mono mixer. If you're going out on a quick remote, you need to mix a couple of headphones together, up to 4 things. Maybe this is exactly what you need. It's rugged, it's not expensive, and it's from Broadcast Tools. So it's a workhorse and it's well built. It's even really easy to use. Look at if you're looking at our podcast, you can see there's not too many buttons on the Pro Mix 4. You got an on-off and a level control for each of the faders, and that's what you need to do a quick remote broadcast. You also have individual headphone controls for up to 3 people, and pan controls as well. Plus, you've got an IFB master control for listening to IFB coming back, program out control, and a VU meter right there. The Pro Mix 4, it has 3 universal mic and line level input channels. It has a balanced line level input. It has a balanced mono program out with a defeatable soft clipper. So you don't have to worry so much about your excited sports guy yelling, "He shoots, he scores," and clipping the thing. Has a built-in USB codec for computer audio playback. So you take the Pro Mix 4 out, you hook it to your laptop, bam, you've got audio in and out of your laptop just like that. And you can use a clean feed, you can use some other kind of codec, you can use Skype, you can use vMix call like we use here on this show. It has a mix minus output as well, plus an LED output VU meter and full duplex talkback capability. An on-air tally warning light relay output. There's your event and tally right there. And it can drive multiple of the Broadcast Tool AHR1 Plus headphone systems. So it'll put headphones out directly on this, but you can also have these little boxes for each of your talent, the AHR1. So that's pretty cool too. This is a simple device, and you know what? I tell you what, there's more times than not, you need a simple device to go out on remote to the high school ball game, to the parade coverage, to the remote at the car dealer, all kinds of possibilities here for the Broadcast Tools Pro Mix 4. Now, where do you get your Pro Mix 4? Well, you go to Broadcasters General Store. I was just there about a month ago. These are such wonderful people. I mean, I love the folks at Broadcasters General Store. I think anybody who deals with them can vouch for how upfront, honest they are. They got sharp pencils there. Sometimes I'm really shocked at the prices that they give. Years ago, I worked with a guy named Sam Phillips, and Sam's the guy who discovered Elvis, right? And he owned the Sun Records, and then he owned Phillips Recording Service. Sam would call me up and say, "Kurt, I need to buy another mixing console. You get on the phone with them folks over at Broadcast General Store and get them to get their sharp pencil. You call them one of them pretty girls over there." Yeah, that was Sam. So they're great. The phone number, 352-622-7700. Easy to go to their website at bgs.cc. And I really thank Broadcaster General Store and Don Wingett at Broadcast Tools for sponsoring This Week in Radio Tech. Check them out. You'll be happy you did, as I have been many times. All right, it's episode 471 of This Week in Radio Tech. Chris Tobin's along. Chris is at a diner. Chris, have you gotten anything to eat yet? You got a cup of coffee or what?
I've been eating some sirloin steak, mashed potatoes with garlic, some spinach with garlic. Yeah. And started off with split pea soup and some nice croutons. Yeah, that's the way to go. That's how we travel. Well, listen, if Anthony was here, we'd be having a good time with some Screech and other things, but I'm not going to get into that. But Anthony's presentations on what we're talking about tonight on this netcast is spot on. So you got to find out some interesting things and be like, wait a minute, I had no idea that existed. And knowing Anthony, he's probably already debunked a few of the things that people claim you can't do with it.
Well, I think we're going to hear about that. So coming up, we're going to hear about NMOS, and then we've got there's something called Mqtt. We'll see that, and then I can't wait. I can't wait for the emoji control protocol. I think the cave dwellers were right with their hieroglyphics on the wall. It's the best way to communicate.
I agree.
Go store, get butter. So, let's turn it back over to Anthony. Anthony, take us into NMOS, if you would, please.
Well, NMOS is, it is again another huge initiative that the CBC is involved in. The CBC is dreaming for something like NMOS to really be inside every product ever, even if it's this little, ProMix 4 type of thing. It can still work for those types of devices because NMOS is a discovery and registration suite of software. So when you have a device and you don't know what it is, you have a node that is on a network. So anything that is considered a gateway, whether it's into the network and out of the network, is considered a node. And those nodes can be made up of receivers, and those nodes can be made up of senders. So like that little mixing console you had there, you have receivers for microphones, and you have receivers for your stereo, your USB in is a receiver. Then you have senders. So those senders are those microphone preamps as well. So those microphone preamps can also be individual multicasts that go out onto the network. And when they consider a source in the NMOS, they break it down because this also applies to video. And this is one of the things that we are extremely excited about because the only control protocol that's readily available on the market to handle this is Ember Plus. So right now, that limits us to only a couple control systems. So by having this open controls protocol stack more well established, it opens us up to other types of vendors and that scale up and scale down. You don't need NMOS if you have a little ProMix 4 sitting on your desk. You need NMOS if you have a couple of 10,000 devices on your network or over 100. And when you start looking at things like Dante Domain Manager, what you have something that is a brokerage of data. So with something like the Dante Domain Manager, you pay a fee to Audinate to scale your control system accordingly. And when you scale your control system accordingly in a proprietary environment, it becomes very expensive. And we at the NMOS, which is the Network Media Open Specifications Work Group, which is a part of the Advanced Media Workflow Association. Again, it's another association, are working towards having an open accepted standard so integrators and broadcasters like yourselves don't have to worry about proprietary, vendor-locked, walled gardened control discovery and connection management. The next slide has the registry. There are different registries. So if you have 5 of these registries, they can all work in parallel to share the node information between themselves. And when you want to share that node information, it's very important to be able to scale to a size of having this many devices. And once you have these devices that are able to transmit and receive, the connection management is handled based on these registries. So if I know there's a transmitter over here because it's registered, and I know there's a receiver over here because it's registered, the connection management can actually bring those two together and make them actually receive multicasts that each other presents. Where it becomes interesting is now event and tally. Boom, loop forward all the way back to event and tally. And well, if I push camera 1 on my switcher, or if I push that Kirk's mic is open, how does that microphone, that tally indication know that it is open? Well, Kirk pushing the fader up, that's an event, and then you bringing the fader down, that's an event, and me pushing a button, that's an event. But imagine if you now have 2 mixing consoles and 1 microphone preamp. Right? Have you ever plugged 2 computer mice into a computer?
Oh my gosh. Yeah, actually, I have. Yeah, weirdly that works. So maybe not the best example. You ever put 2 CB radios into a single antenna? Not so good.
Not so good. Well, when you have 2 mice on a computer, does moving one drastically change where the other one's position landed, or does it just keep going? So if I have a mouse, if I have 1 mouse and I move it, and then I move another mouse, does it keep moving, or does it just like jump to where that mouse was supposed to be?
Oh, I don't know. Okay,
it just keeps moving. So if I have 2 mice and I keep pushing them one direction,
the other one was additive in its instruction to move. Yeah.
Right. So if you have an event of me turning up a microphone preamp, is it me saying increase? Or is it me saying, go to this value specifically? So there are different ways that one can treat an event. So where it becomes extremely cumbersome is if you have 2 microphone preamps, but 7 mixing consoles are subscribing to it. So how do you share those types of parameters amongst these mixing consoles? So right now in the event and tally work group of NMOS, there is, I think it's slide 11, right now there is an established message, and that message structure is synchronized to our registries. So these registries that show up, and I'm sorry about the code, it's not a foreign language, it's in English, it's just formatted bizarrely. Yeah. These are standard JSON structures. So if you showed this to any script kiddie who can program JSON, they would understand how to interpret this message. So every message event, anytime you push a button, one of these messages could be created. And what it does is it says, well, this is the source ID, so that's the box that actually did it. Well, this flow ID, well, it could be associated with that multicast that you are transmitting. Well, there's an event type. Well, that event type, well, here's a switch. It's Boolean, so it's 1 or a 0. And then you have timing. So this is where it gets really exciting. So I can have an event timestamp, which is PTP clock. So if you look at those big numbers, the 153160, that's a PTP timestamp. So I know down to the billionth of a second what time you push that button. And then I can tell you exactly to a billionth of a second what timestamp that leaves my device. And then I can tell you to a billionth of a second when to perform that action. So I could say, well, that action happens 5 milliseconds after I push that button, or that action happens, 2 years from now. It could happen 10 years from now, and I could program that. So it's very tied to this existing thing that we're using in these protocol suites called PTP. So now your events can have PTP-like accuracy. So if you, again, to the, somebody asked me, well, how do I save 50% on my post-production costs? Well, the answer is you do it live. But now imagine if you could take your control information that you've recorded live with PTP timestamps and bring that into a post-production environment. And what we're creating when we do this media-rich events is you're creating something that can be containerized in the future and brought into post-production for some type of augmentation. And how these messages are moved around is this thing called Mqtt. And it is a fantastic thing that is an ISO standard. And NMOS is an IS-07 standard, but it's not an ISO standard like Mqtt is. Mqtt is it's a publish subscribe system. So when my mixer makes an event, it would publish that event and devices that wanted to subscribe to that event would subscribe to that event. So I push a button, it creates this message that gets published to a tree, and that tree can be in this MQTT structure. So you can have a tree would be like Studio One, desk, left, floor, something, for example. And that event could be subscribed to by the things that need to subscribe to it. So your console would subscribe to the button, and your light would subscribe to the console. And once you have these messages that get moved around through this brokerage system, you can pretty much program anything and everything to do anything you absolutely want. And the reason why MQTT is so popular, it's called a message querying telemetry transport. So it's super popular in the IoT Internet of Things realm, and it doesn't exist. It's not an invention of the broadcasters, and it's not an invention of a bunch of AES-67 guys at control protocol parties sitting around going, hey, you know what we should do? We should do this MQTT thing. It is outside of what the audio engineers and the video engineers have done. And by leveraging that, we're able to take advantage of technology that is extremely, extremely well established. And NMOS is under development. It's not finished, but neither was MIDI up until a couple of years ago, and now they're on to version 2, and everything is in development. And this is one thing people are afraid of when it comes to standards is, well, it's not standard by this organization, or it's not standardized by this organization. It's de facto standards. You look at the Studio Hub stuff, and that's a de facto standard in the industry. And now there's AES-72, which is a different type of standard, which uses a very similar type of construction and cable construction. So standards are very loose. And right now, we, the CBC, are really putting our money, Canadian taxpayer money, into this type of request. We are asking all of our manufacturers and every one of our proposals to have an NMOS capable device, and manufacturers are delivering. You're seeing video companies, audio companies, you're seeing broadcasters of any shape and size who want to get in on the 2110 profile of doing AES-67, and we want interoperability, and we want to make it accessible for everyone. So it's expensive, and it's a lot of time for us to invest working with these standards organizations and working groups to ensure that it's very much a trickle down of our developments to consumers of the future.
Chris Tobin knows what I'm going to say right now, and that is that this is the beauty of standards. There are so many of them.
This is true. It is true. Very true.
So, unfortunately, we're going to run out of time because we got a couple more things to cover and a final spot break. Anthony, you are proposing, and I don't know if it's tongue-in-cheek or real, but the fact that you're proposing this to me makes sense because I think it helps give clarity to what we're trying to do with control standards, and that is this emoji standard. And it kind of turned on a light bulb in my head. So why don't you wrap up this segment by telling us about the emoji proposal?
So I love rabbit holes. Do you know what is the most efficient way to say microphone in text? And I got to thinking that there's an emoji for a microphone. So how small is that? And it turns out it's 4 bytes. I can say microphone in 4 bytes, but then I can also say name badge in 4 bytes, or I can say information in 4 bytes, or I can say ID in 4 bytes, or I can say plug in 4 bytes. So I created this thing which I like to call the Emoji Description Protocol. And the Emoji Description Protocol is, we needed a way to, like, I'm an A2. I was an A2 before I was an engineer, and we did a lot of spreadsheets. And the spreadsheets kind of told you what was happening with that microphone. So here's the Emoji Description Protocol. So I declare a microphone called Kirk Harnack. Well, there is a name badge, and it says, well, he is the announcer. There's an information. Well, he's got white hair and glasses, because when there's like 10 guys on stage, you don't know who's who. Warning. There's a warning. Well, he's got a low, deep voice, so just heads up. Well, what kind of microphone is he using? Well, he's using an EV-RE20. There's a little ghost, so that's phantom power. No, there's no phantom power in our RE20. Then it goes down plug number 1. Then it goes down a snake, red, goes down my red snake. Then I apply 60 dB of gain. So the sensitivity of that microphone, I need to apply 60 dB of gain. And then I want to apply an EQ. So the Emoji Description Protocol gets extended into, well, what is a preset EQ? Well, there's a little emoji for a low pass. Well, there's 80 hertz. I want to knock down -2 off Kirk's rumbly voice there. At 4.5K, I would like a Q. So that Q there, that's actually an emoji. That Q is an emoji, and I would like a Q of 1, and I would like to knock it down 2 dB. And then at the high end, 13K, I want to knock it down 2. So that wraps it up into a preset EQ. And now I want to sum a whole bunch of things. So I create a little palette, and that palette is made up of people at their levels. So you have a web of people. Person 1 at -10 and person 2 at -10. And this, can be consumed by someone. So mix number 1 is -20, run it through that same preset EQ, and I give it back to person 1. So what I'm trying to do with this is illustrate that there are many ways to describe a signal or describe how you want to mix something. But I found that these hieroglyphics, like if I move them between mixing consoles or move them between, venues or move them on a patch sheet, I can define anything in a very, very clear way without any of that, JSON presentation or any of that computer code. None of that computer code.
Chris,
I just want to sit there on my iPhone and tap it in on my emojis. Yeah, I want my microphone.
I'm laughing, but I'm amazed at the brilliance and brevity here. Chris, what do you think about emoji code?
I think it'd be great. Why not? Let's have some fun. I mean, that's the problem with broadcast engineers. No fun.
There is no fun. There is no fun. But, you look into the emoji, there's an emoji wiki, there's a Wikimoji, I don't know what it's called. But, there's level sliders, there's control knobs, there's electric plugs, there's headphones, there's laptops, there's up, down arrows. All the transport commands are there. It's crazy. It's absolutely crazy how much is there in the Emoji Description Protocol. But I'm working on that. It's at yeah. I'll send you a link. It's phasebook.org, phabook.org is where I have some of my research posted.
That looks interesting.
My crazy emojis.
If that goes anywhere, we need to do a whole show on this and a whole learning show on what the different things would stand. A lot of those made absolute sense. Like, well, mix the paint palette. Yeah, mix these things together. And the web, grab this thing and put it in the mix. That's great. I love it.
I'm glad you enjoy it.
I sure am. Hey, it's This Week in Radio Tech, episode 471. Kirk Harnack here, and Chris Tobin is at a diner in Long Island enjoying a steak, and I wish we could just join him because I'm getting hungry. And Anthony Kuzub is our guest. He is at the CBC in Toronto and responsible for an amazing amount of getting stuff to talk to each other. He's taking us through these different protocols. But there's something you can't miss, and that is what is going to end up round out our show, and that is this amazing tip from Anthony that I wish we knew about years ago. Well, it didn't work years ago, but it works now, and it's a great idea to solve a certain problem that broadcasters are often faced with, and it solves it very, very nicely. So that is coming up in just a minute. You're watching This Week in Radio Tech, and our show is brought to you in part by our friends at CalRec. We'll be right back. Hang on.
CalRec's Type R is a modular, expandable IP-based radio system featuring 3 slimline panels, a fader panel, a large soft panel, and a small soft panel easily configured to give the operator full control. Layouts are saved and recalled quickly between shows. A single 2RU core with integrated I/O gets customers up and running fast, and that single core can power up to 3 independent mixing environments with no sharing of DSP resources. Available in 4 DSP packs, and as your station grows, larger packs can be added, enabling it to grow with you. Power to the surface is supplied via standard PoE switches, keeping cabling to a minimum. Type R is fully AES67 compatible, as defined by SMPTE 2110, which means that it is also compliant with NMOS discovery and connection management specs. All these features combined make Type R the most flexible radio console you can buy. Find out more at calrec.com/TWiRT.
And thanks a lot to This Week to CalRec for sponsoring This Week in Radio Tech at calrec.com/TWiRT. Hey, we're also brought to you in part by your favorite, these cables, Studio Hub cables. Thousands of radio stations have used these to make their wiring go so much faster. And I certainly have used lots of Studio Hub cables. These are the cable adapters right here. This one has a female RJ45 wired in the Studio Hub standard, balanced audio. And you can run unbalanced audio across that. And if you're willing to pick up some crosstalk, but you don't want to do that. And then on the other end, you get them terminated in whatever kind of connectors you like. This one has male XLRs. You can also get female XLR cable terminations. You can get things like a 1/4-inch tip ring sleeve termination. RCA, that would be an unbalanced connection, but that can work well depending on what you're running it to. And even the 1/8-inch cables. So just lots of different adapter cables are available. In fact, you can also get them in a different style, and that is with a male RJ45 on one end. So if you've got, if you want to just run this really close to, really close, but they also have a 6-foot version as well. Lots of these 6-foot cables available with male RJ45 to whatever terminations you want on the other end. If you've ever wired a radio station, a television station for audio, you know what it's like to have to solder stuff. And not that there's anything wrong with soldering, but good golly, it takes time. And the chances of burning your fingers and getting it wrong and making a mistake, no mistakes with these. You plug them in and they work. And if you've used Studio Hub, you know about the quality of the cables. They don't come apart. They're well molded, and they have found the right techniques to get audio cable to go into a little RJ45 plug or jack, and they're highly reliable. So I'm excited about Studio Hub, have been for years. We've had their inventor, Dan Braverman, on the show before, and now Studio Hub is all available from Angry Audio, angryaudio.com. And that's available either direct from the website or call your favorite dealer and tell them, I want Studio Hub from Angry Audio. And when you do that, for every one of these female RJ45 adapters, and I think this is like the original Studio Hub adapter with a female plug on there. For every one you order, you get a free 7-foot Cat 5 patch cable, certified. Yes, and on the label, look, this is really convenient. They even give you the wiring pinout for Studio Hub, which, by the way, I use that all the time. I'm wiring a studio. Invariably, I will have to solder something because I didn't think ahead. And so I'll need to know what the pinout is. You just Google Studio Hub pinout. Bam! You're presented with the color codes for RJ45 cable, whether you're using it for AES digital. Yeah, just one pair is used for that. Or whether you're using it for mono balanced audio, one pair for that, or stereo balanced audio, or stereo balanced plus power. That's another standard in Studio Hub. So check it all out. Go to angryaudio.com, or if you know what you need, call your favorite dealer and say, nope, I don't want any substitutes. I want the actual Studio Hub cables made in the same factory that they've been making them in for years, with the same people and the same jigs and the same molds and the same quality. Now available from angryaudio.com. All right, it's Kirk Harnack and Chris Tobin. He's at a diner in Long Island. Nothing could be finer than dinner at the diner. Something like that.
Nothing could be finer than dinner at the diner. That's true.
And Chris, is it cold there? Are you nice and snugly warm there in the diner?
Diner is snugly warm and enjoyable. Families are rolling in. There's some good food at the counter. I'm actually enjoying a peanut butter and chocolate cake. We'll leave this up to you.
Oh my gosh!
There you go.
Geez.
Oh yeah, look at that. That's good stuff. And because I'm in the middle of getting the other things going on, I have a coffee to go, my takeaway. There it is.
There you go.
It's good stuff. But yeah.
So what's your travel mode? Are you going on a train, or are you driving, or what?
I'm a motor coach, taking a car. We're heading out, taking care of some business. It's good stuff.
You guys.
Yeah, go ahead.
You New York guys with your motor coach words. I would never use that word. That sounds so high class.
I'm just having fun. Motor coach. It's a car. I'm going out in a car. You know. My buggy whip is back at the house.
All right, we got about 6 or 7 minutes, and Anthony Kuzub, our guest, he's an engineer, a senior engineer at CBC, solves all kinds of problems that have to do with blue cables and RJ45 connectors. And That's Anthony true. Is going to talk to us. He's going to talk to us about this technique that I didn't know was available. So, Anthony, describe it best you can, and we may have we have a graphic about it too. So, take it away, Anthony.
So one of my colleagues at work, Francois Legrand, who is obsessive about going deep into things, showed me this thing in Chrome that you can do is called WebRTC Internals. So if you bring up the slide here, if you navigate a Chrome browser to Chrome://WebRTC-internals, you're presented with this screen. And so right now, this conversation you and I are having is done through WebRTC, and Google Hangouts is done through WebRTC. I don't know if Skype would be as well. Anything that uses WebRTC, the Chromium browser intercepts it and manages it. So there's this little checkbox here called Enable Diagnostic Audio Recordings. So of course, I checked it, and it gives you a prompt that says, "Oh, what do you want to call this session?" So we can call it today's session, whatever it is, and it generates some files. And what it does is it does 2 different wave files, and it gives me and it gives me you as 2 separate wave files. So if you do this and I do this together, there will be 4 wave files generated. 2 of them will be compressed, and then 2 of them will be fully uncompressed. So if I want to do a double ender, you and I, we both do this together, and then we take our 2 audio files, we exchange our audio files, and I get your 24-bit 96K or what 24-bit 48K file, and you get my 24-bit 48K file, and you can just sync them up together, and away it goes, and it records it records it perfectly. So it would record me here with all of my whatever, and then it would record you separately, completely isolated voice tracks between you and I having that conversation. And I thought, what a fantastic way.
For those who don't know, and I only know what a double ender is because I've dealt with some public radio people, because in commercial radio, we typically don't have this technique called a double ender. But in the U.S. anyway, NPR was really big on doing this because they wanted high quality audio before the days of IP codecs. And we still, if you want to get a great interview with your governor, your congressional representative, or somebody, they may or may not have an IP codec in their office, right? So if you do this double ender, and they used to do this on cassette, right? And NPR would send a guy out on a bicycle with a cassette recorder to put the cassette recorder next to the senator's, microphone or telephone and record that. Then we'll bicycle it back to NPR, and they'd have the local recording and the senator's recording, and they'd line them up, which was not always easy. And they do this, but now we can do this inside the browser, even if you don't have fabulous.
You don't need any tools. It's built into Chrome. It's built into Chrome, and so we use Meet for meetings and stuff like that, and of course you got to be careful of you can essentially record anybody's chat conversation when you get down to it. So you got to be super cool about it. You got to make sure that people are aware that you are recording, and you gotta be ethical when it comes to this kind of collection of data. And we all have IP codecs at our desk. I have Google Chrome, and when it comes down to it, this WebRTC is connected with Session Description Protocol, and
SDP.
all of these WebRTCs. Oh, it just all comes down together. So if you want to solve a problem in the audio industry, look to the telephone industry. They solved it 20 years ago. And we are slowly starting to see the secrets of the telecom industry really work to our advantage in the audio industry. That's for sure.
So, Chris, while Anthony was telling us about this, I went to that Chrome://WebRTC-internals and hit that create dump button. And oh my goodness, there's so much metadata here about the session that's going on. I had no idea. Have you seen this, Chris?
No, I have not. That's the first I've heard of it, which is pretty cool. Doesn't surprise me.
I'll include this in the show notes in case you are driving or can't write down or remember the Chrome command. But so you have it in there. You can see it. You can play with it if you want. You can read about it if you want. And there's Google information about doing this. Anthony, any last words about this? Chrome gets you home.
I guess Chrome does get you home if you're talking about a double ender.
One thing. I'm sorry, Chris. Go ahead with your comment, Chris.
Oh, no. That was Anthony.
Okay. So, Anthony, we've talked about on this show some of the aspects down in the weeds of these different control protocols like MIDI and AES-70 and NMOS and MQTT and Emoji. And, it seems like down the road, whenever you can come back and talk to us some more about this, I'd like to understand a bit of a practical point of view, how to use not necessarily each one, but the ones that you're really using there at CBC, and maybe what you do when you have to connect two of these protocols together. What's the least common denominator? And, it might be GPIO, but hopefully we can get above that point at some point and have, protocol translators if we need them.
Well, hopefully we have no protocol translators. It's every engineer wants to engineer the best thing. It's the not invented here syndrome when it comes down to it. Variety is the spice of life, but when it comes to control protocols, no thanks. I just want functionality. That's what really gets me on the air. You put too much spice on something, you choke on it. And right now the industry is choking with all this uninteroperability. And I'm really playing for a tie. I don't want, the only people that are winning in this battle are not the broadcasters and it's not the customers. And when we are at a point where the customer is winning, I will be much happier. Much happier.
Yeah. All right. Hey, Anthony Kuzub with the CBC. Thank you so much for being on This Week in Radio Tech. And I know you and Chris are friends. You've talked in Toronto before, and we hope to have you on again.
We're all friends. We see each other across the world. I think I saw you in Amsterdam a couple times and Vegas. But now I don't have to do those things. So I just get to work. That's amazing. I just get to work now.
If I can visit you in Toronto and just spend a couple hours in your workshop, that'll be great.
Anytime.
All right. Chris Tobin, thank you for joining us from an unnamed diner in Long Island.
No, it's not unnamed. Hang on a second.
Oh, it's not unnamed. You got it?
Yeah, let's see if that works. Premier Diner.
The Premier Diner, of course.
Yes,
because Chris wouldn't eat at the Dewdrop Inn or the second-rate diner or Mel's Diner.
That's true. I wouldn't go to the Dewdrop Inn. Mel's maybe, but not Dewdrop.
Hey, Chris, last week I made a big mistake, and I said we were going to have the John Lyons seminar this week, and I totally made a mistake. I don't know where my brain was because we had Anthony Kuzub scheduled for weeks here. Next week, we're going to have the John Lyons seminar on the build-out of the antennas and transmitter building at One World Trade Center. And as we mentioned last week, John Lyons did pass away in the past few days. And so I thought this would be a fitting tribute. And it's a show I'd like to see again. So we're going to have new commentary from you and me about this. And Chris, Tom Ray is going to be able to join us as well. Tom was a dear friend of John Lyons as well. So it'll be you, me, and Tom Ray and the John Lyons seminar. How about that?
All right, then I should make arrangements to do it from the 90th floor at World Trade Center.
Oh my gosh, you could do that?
I do have access. I do have, yeah.
Well,
You got keys.
that would you have keys. That would be super cool.
Yes,
Okay.
I do. Yeah.
Hey, we got to go. I know Suncast needs to get on out of here. Anthony, thanks again for joining us. We appreciate you. We will see you again another time. Okay.
Happy National Sound Check Day, by the way. It's 1212, right?
Well, that's right. It is.
December 12th. It's 1212, National Sound Check Day.
That's right. Chris, thank you for joining us. We got to go. Thanks to Suncast.
All right.
Great job, Suncast. I appreciate you. You too, Chris. And thanks to Andrew Zarian, the founder of the GFQ Network, for making all this available. I'm Kirk Harnack in Nashville at the Telos Alliance Studio, and we'll see you next week on This Week in Radio Tech. Bye-bye.